speed. Liquid level or level. So these are some of the that comes up. Oh, yeah. Phrases and separate. So we talk about speed, position, weight, right, level, proximity, light. And we'll level, temperature. And then the next thing we're looking at probably pressure, I think. And we talk a little bit about flow, even though we don't have a lot of flow sensors here. Probably won't have enough time to get into orientation. We'll try to talk a little bit about that. Usually, y'all know what orientation means, right? Okay, there. So we might talk a little bit about some of the vision sensors. Usually this deals with camera systems, which are still relatively new in the control market, even though they're getting more and more into it. The problem we had a long time with camera systems and computers is the computers were not fast enough to process the information from the camera. So some of y'all that's in my other class, the camera we have over there has a very low frame rate on it. It's got a really good picture, but a very low frame rate. Someone's trying to catch things in motion, it actually comes up and looks like they're stationary even though they're moving. And that's a lot to do with the camera and of course what the camera actually connects to. But we have some video systems and computers now that are extremely fast. I've seen videos of where they do sorting of different fruits. I hadn't seen big, but where they literally have a picture of what a peach is supposed to look like. And then while it's moving down the line, almost at breakneck speed, that camera system's looking at it. If it sees a piece of fruit that don't match what it's supposed to be, what does it automatically do? It rejects it. I've seen one where they shoot light things across a gap, and up above it, they have a camera system, and they have a bunch of air nozzles up there. And it's really neat. And it'll shoot them things across that gap because they're so light. And it's got a camera system up there looking to see if it matches what it's supposed to look like. If it don't, it has a little puff of air that comes out and just blows it down inside the trough. And it's doing this at speeds that we couldn't. There's no way in the world we could do that. So orientation, shape, and size, has a lot to do with that little vision system or camera system that's available to us now. And it took a long time now. Now, they're actually starting to use it in robotics where they can get these big robots, instead of caging them up, they put them out on the floor. And then they have a vision system up there that's monitoring. And if people walk into the range of the robot starts slowing down. And literally, so it don't ever really stop until you get inside that restricted space. But what it does is it starts slowing down, and the closer you get to it, the slower it goes until you get into the restricted space where it could actually strike you. So there's a lot going on with vision systems. We got one vision system on our ABB robot, and then we got one on the Motorman too. And then we've got a camera that came with the Amatrol line that's locked up in there that we'll have to use. Anyway. So temperature, very, very important to sense temperature, because usually when things get too hot, or even when things get too cold, then you start having problems, right? And so we have temperature sensors like monitoring bearings and all kinds of stuff. Of course, food process plants do a lot of cooking and freezing and stuff like that, and they have to maintain pretty constant temperature to meet health requirements. The type of temperature sensors that we'll look at is bimetallic temperature sensors, thermocouples, RDTs, thermistors. Infrared is becoming pretty popular too, and the integrated circuit temperature system. So these are actually complete circuits inside a single chip, and we do have some of those, which are pretty neat. And that will
There's a infrared camera DIY project you can get. It's like answers. Put it all together.
yeah. So they've got some really neat features. Even in the HVAC program, the infrared's becoming very, very popular, temperature sensitive. Used to, like on these vents right here, to see if they would get the right temperature of air, they would have to get a ladder and they'd put a thermometer that looks a lot like a meat thermometer, and they'd stick it in the vents. They don't do that anymore. Now let's do what? They'll shoot infrared up there and you'll come back and
That's actually one of the more common ways of troubleshooting circuits.
yeah, it is because of the heat. So unfortunately, we have several different scales that some of us are familiar with. Centigrade, which to me makes more sense than any of the scales. Unfortunately, over here we're doing what we call, some people call the centigrade scale the Celsius scale. The terms are the same thing. What's nice about the centigrade scale and the Celsius scale, it is based on 10 for one thing. And what they did when they set up that scale is freezing is what? 0, and boiling is 100. But unfortunately, we deal with the Fahrenheit scale. Now, we've been with the Fahrenheit scale so long, it doesn't give us much problems. Just like miles don't give us much problems when the rest of the world is over on kilometers that moves in 10, right? So, the Fahrenheit scale, freezing is based on what? 32 degrees, and boiling is 212, which is all kind of wax. 5/9, it's either 5/9 or 9/5, yeah. To go between the Fahrenheit and the Celsius scale. And you go from the Fahrenheit scale to the Celsius scale, the first thing you do is subtract what from 32 to get a 0 reference, right? And then you multiply it by 5/9. Because for every 5 marks on the centigrade scale, there's 9 marks on the Fahrenheit scale. They line up. So that's where those things come from. Then we have something called absolute zero. And this is temperature below which temperatures don't exist, which is pretty good. And this is when everything basically almost comes to a stop. Anything that's in motion does what? Basically stop. We have 2 scales that are based on 0. We have the Kelvin scale. This is using the same spacing as the centigrade scale. And then we have the Rankine scale, which uses 0, but it's on the same spacing as the Fahrenheit scale. So 0 degree Kelvin actually equals a minus 273 degrees centigrade. And 0 degree Rankine actually equals a minus 459.67. Now this is kind of like infinity. As far as I know, absolute 0 has never been obtained with the calculator. So when we measure temperature, we're going to measure it either in centigrade, we're going to measure it in Fahrenheit, or Kelvin, or Rankine. We'll start dealing with different components, especially centigrade. We usually deal with one of each relative to that. Are we okay? Everybody okay? So one way we measure temperature, and this was done for years in the house, and some of y'all might still have these things, is using what we refer to as a bimetallic strip. And I think we talked about this in this class. What does that mean when we talk about a bimetallic strip? Two metals that have different coefficients of expansion.
So like a circuit breaker?
Circuit breakers use, some circuit breakers use magnetics, and then some circuit breakers use bimetallic strips. And some circuit breakers use a combination of both. Most home circuit breakers is basically a bimetallic strip, and you can see it if you ever pop one open. So this is the way our old thermometers used to be. Oh, keep getting that over. I thought they were looking for my camera. Not working. So see if it'll focus in. So this is an old thermostat. So what we would do, of course, is we would set our temperature over here. And then this is a wet reed switch, right? Or a lot of people call this a mercury switch. And the mercury switch is mounted on a bimetallic strip that's coiled into a spring. So what happens is when we heat this thing up, we have two metals that are bonded together that have different coefficients of expansion. So that means they expand at different rates when we heat them up. And then, of course, we've got this wrapped in a coil. And what you're doing when you check the temperature is you're changing the tension of the coil. That's all you're doing. That makes sense? And then, of course, what happens is when it heats up, this thing when it heats up, it tries to uncoil. When it cools down, it tries to do what? Contract. Because of the two metals. The analogy I like to use is of course, that's a pressure sensor, but when we use the blow things, right, at birthday parties, and we blow in them, they want to coil, or we can suck in on them while they do. They retract. Well, this is doing it, but it's doing it with temperature. And then, of course, what they've got is they've got a switch mounted right here. So when that thing coils or uncoils, so when we set a reference, when we set a temperature, the switch is basically going to be at a level, and it's either going to do what? It's going to tilt one way and set one set of switches, or tilt the other way, depending on if we got the thing set for temperature or heat. So these guys are pretty easy to understand, but we could also attach another sensor to the thing. So we could take a potentiometer and connect to the bimetallic strip. So when the bimetallic strip moves, it does what? Turns the potentiometer, and that way we could get a voltage that's proportional. So this is kind of like a digital. It's kind of like setting the span on a digital sensor, where you set where it actually trips, right? But all we do here is just rotate this, and then we set the tension on that spring. So what happens is when it gets colder, it moves in this direction, right? Understand? And then when it gets hot, it does what? Yeah. So when it gets hot, it would move in this direction, and then where it gets to a certain, and of course this is where they use to calibrate the thing. So this is what you'd use to calibrate the thermistor, or not the thermistor, the bimetallic strip. And these are probably in a lot of houses that's still out there. You know, a lot of people, of course, your new houses are going to go to digital thermostats, right? You understand that. But if you got a house that's been out there for a long time, these guys here work great. I mean, they're really pretty accurate. Thermistors, which are solid state temperature sensors, are good, but they're non-linear, so they're not really extremely. They're accurate, but they're not. It don't. It's line. When we use the term linear, what does that mean? That means something varies in a straight line. So if a device was linear, then what that would mean is that if it generated volts and then it generated a temperature, then that means that the volts across it would vary at the same rate as the temperature. Either it would have a positive temperature coefficient or a negative temperature coefficient. So if it's got a positive temperature coefficient, that usually means its opposition would go up when the temperature, its opposition would go down. If it's positive, its opposition would go up as the temperature goes up. If it's negative, it would do what? It would go down. Most of your thermistors are negative. So y'all can look at this. Like I said, this is an open thermostat. So basically, a lot of your home circuit breakers work off this concept where they actually pass the current through the strip. And of course, metals have resistance. There's no such thing as a metal that has no resistance, right? You understand that? So if we push current through resistance, then what does it do? It drops the voltage, but that's not what I'm looking for. What does it do? Because what are we talking about? We're talking about temperature. So if I pass current through a metal, what does it do? It heats it up, right? You understand that? That's why conductors get hot, especially if you use the wrong gauge. Because what determines the temperature of a metal? What determines the temperature? What determines the resistance of a metal? Yeah, that's what we rate them in, but that's not what determines its conductivity. So we can talk about of course, normally we don't use conductivity. They use a term called ampacity. But what determines the resistance? So saying the conductivity would be saying, I say what determines the resistance, and you say the ohms. Right? You understand? Make sense? Yeah. That would be like you saying, what kind of mileage do you get out of your car? And you say miles per gallon. Right? You understand that? So conductivity is a rating of the metal's ability to conduct. In electrical, we call it ampacity. So if you look at inside the National Electrical Code, they have what they call ampacity charts. It basically gives you what determines how much opposition a conductor is given. Yeah, so the size of the conductor, right? Okay. What metal it's made out of. So different metals have different conduction, right? You understand that? So we call it the gauge, then the length, the length of it, and then the temperature. So most metals, their resistance goes up with temperature. In fact, all metals that I know of. No metal that I know of, resistance goes down. Of the known metals, I'm not saying they're from a metal. Unless you find something else big. So that's why when you wire up. So if you were an electrician and you did wiring, you need to know what gauge wire to pull. Right? I understand that if you pull the wrong gauge, if you pull a wire that's too big, then you waste a lot of money. If you lose a wire that's too small, then the wire's probably going to get hot. Right? And then once it gets hot, its resistance goes up, which is not good. this is why wires burn up and you have a short circuit. So you have a short circuit and your power supply can't regulate anymore, so its output voltage drops down. You know, it's a regulated power supply. Regulated power supply means it tries to maintain a constant output, even though you're putting varying loads on it. Well, the problem is that it can only regulate over a certain range. So that means you got your cruise control on your car engaged, and then you start up a 45-degree incline, that car is going to slow down. Right? You understand that? Even though you've got that, that capability. So, what we're dealing with is your power supply drops down, and then the wire heats up. Well, if the wire heats up, if the resistance goes up, but the output of the power supply now can provide more current, right? You understand that? So its voltage will start going up. So what happens? Your wire starts generating a lot of heat, and eventually things are going to happen, right? In your house, what usually happens first, well, it burns off the insulation. And when the insulation melts off, and you got all this exposed conductors out there, which usually causes short circuits. And now you're working with Alabama Power, which can provide a lot of current, right? You know what I'm saying? And then what usually happens where your house gets. So choosing the right wire size, and also doing your terminating and splicing of conductors. So what's the function of a conductor? Conductors have one function in life. What are they used for? To get current from the source to the load. It's their function in life. You understand that? So all conductors have to come to an end sooner or later. And the art of bringing a conductor to an end, we call it termination. So if you don't know how to terminate a conductor, so in my other class, we're going to start looking at soldering. A lot of conductors are terminated by soldering. And in splicing, this is when we take two conductors and we join them together, right? So most of your problems people have in their conductors, if they use the right size, they don't terminate it correctly or they don't splice them correctly. So we got a course called cable splicing and termination. So there's a lot more to it than this column together. So bimetallic strips are really, really neat, and they're very simple, right? Because there's really no solid mechanical. So your circuit breakers work on your house circuit breakers. A lot of your big circuit breakers, like you run in, they use magnetics. So what they do is they run the current through an electromagnet, and then when the current gets up so high, the magnet breaks the circuit for you. And then after, of course, circuit breakers, what advantage do circuit breakers have over fuses? Yeah, you can reset them. What advantage does fuses have over circuit breakers? Man, but that's not the big advantage. The big advantage of fuses is they're cheaper. Now go down at Lowe's and look up a 15 amp fuse, 125 volt fuse, and look at a 15 amp circuit breaker. You're going from cents to dollars, right? You understand that? So big advantage fuses. And this is why in industry you still have a lot of wires. You have a lot of fuses. A lot of fuses. Especially on motor circuits and stuff like that. You have a lot of fuses on this one. So bimetallic strips, this is basically, so we have what we call an ADIC, which basically means something is in a wire, in a coil. So these are different types of sensors. This is basically the sensor that you're looking at that I passed around, so it's in the circular. This is very popular inside of temperature sensors, where they put the ADIC down sensing tube. So they'll have a metal tube that actually senses. The helix will be running down, the spiral will be running down inside the system. clap it on one end, so what happened is that when it heats up, this thing is either gonna turn clockwise, it's gonna be turn counterclockwise, depending on how the bimetallic strip is. So this is basically what you're looking at there. It's nothing but a bimetallic strip, and it's got some type of sensor on it. Here they're using what we refer to as a wet reed switch. A lot of people refer to it as a Mercury switch, which is becoming a lot less popular. And why is that? Now, mercury is a part. The problem with mercury is the molecules of mercury are so small they'll go through your skin. So mercury is dangerous to handle, get into your hand. And what we was talking about in the other class, lead is not dangerous to handle because the molecules of lead are not big enough to get through your skin. Right? Where we get in trouble with lead is getting the stuff in our mouth. That's what they're talking about, lead-based paint. Kids come in and starts peeling, and little kids. Y'all ain't had kids yet. You'll find out these little kids don't eat. If they pick up something and they're in that range about 1, 2 years old, when they pick something up, and usually what does that? Goes right into that mouth. So mercury is real dangerous. So you're not, but we still have a lot of these devices out there. So these mercury switches. We used to have them in alarms on cars. So somebody tried to jack your car and steal the tires off of it and set the mercury switch off. Now they use it. The bimetallic contact strip, pretty straightforward. So we allow the current to pass through this. Now don't have much resistance, right? You understand that. But every wire has resistance. And if you put enough current through any conductor, it's going to get what? It's going to get hot. So this is pretty straightforward. With contact. A lot of times, like on a circuit breaker, they set this thing out. I need to bring one in. They're hard to take apart. They rivet it together. Usually when I'm trying to drill the rivet out, something happens. But it's sitting on it's got a spring that's pushing it too. So when it bends, it pushes and the spring snaps down. And then it latches in the open position on the circuit breaker. And every little you gotta do you have to reset it. So to reset these things, you have to do what? You have to turn them all the way off and then turn them back on. You can't do it, by the way, you can't do it as soon as they trip. So you gotta give time. You gotta give time for this time to have a trip to come off. So that would be, you can't reset them instantly. We use a lot of bimetallic strips for overloads in low voltage motors or single voltage motors. They use a lot of bimetallic strips. Unfortunately, some of them they automatically reset. You gotta be careful. A lot of your HVAC system motors in your heating, ventilation, air conditioning system use bimetallic strips that they automatically reset. So you got a motor out there that's not working, you get out there and don't disconnect or anything, get your hands in that blower and all of a sudden that stuff will reset. It's going to cause you some problems. The bimetallic strips with contact. Pretty straightforward. So I'll see this weekend. I'll see if I got some old circuit breakers I got out of the building before we tore it down. I'll drill them out and try to make them so you can actually see how it works. The circuit breaker and see how it works. This is basic operation of residential circuit breaker. So this is pretty much the way it is. So what would happen is bimetallic strip would heat up and do what? Gotta move over, the spring's trying to do what? Break contact, so the bimetallic strip is in this thing right here. It won't come back out, right? You understand that? Until you do what? Yeah, until you come over here and push this thing. So normally what you have to do is go all the way and then reset it. And then pop it over. So this is pretty straightforward, but the actual current of the load does what? It passes through the strip. It's usually inside a little brass container at the top of the circuit breaker. I'll show you that. So this is pretty operation of a residential circuit breaker. But most of your residential circuit breakers simply use bimetallic. If you ever take one apart, this will be, usually they look copper, but it's inside of it. In this